So we're going to look at how to classify real numbers. You've probably classified numbers before. We're just kind of expanding what you may have done before. All right, so you've probably seen when you classified before something that was similar to this. So you have several groups of numbers, and the smallest box in the middle represents the smallest set of numbers, and then as you get bigger, the group of number grows. All right, so in the very middle here, you have natural numbers. That's the smallest group of numbers. The natural numbers are also called the counting numbers. And so they're the numbers you learn to count with. So when you first start school and they teach you to count, what do you start with? You start with 1, 2, 3, and so on. All right, so your natural numbers are all those numbers you count with. So it would be 1, right? Sorry, it'd be 1, it'd be 2, 3, okay? But you could keep on counting, right? You could get up to 100, and then if you want it, you could get up to 8,000, right? So it could be pretty much any number you can count to, right? And the longer you count it, the bigger these numbers would get, all right? So those are your natural numbers. The whole numbers are all of those numbers plus the number 0. So it just includes one extra number, 0. I remember the O in whole. It kind of reminds me of the 0, so that's how I remember what the whole number is, how it differs. All right, so again, you're going to have all of these numbers, the 1, the 2, the 100, the 8,000, and then you're also going to have 0. All right, so then you have your integers, or the next set of numbers. They're all the whole numbers plus all their opposites. All right, so if I have 1, the opposite of 1 would be -1. If I have 2, opposite of 2 would be -2, and 3 would be -3. So it's all of these numbers I had before, but really all their negatives. Okay, so it's going to be the 1, but it's also going to be -1. It's going to be 2, but it's also going to be -2. Or 100 and -100 could be 8,000. It's also going to include -8,000, and then it's also going to include 0. But the opposite of 0 is still 0. All right, and then the last part on this side of the system is the rational numbers. The rational numbers we've been talking about. So hopefully you'll remember that they're all the integers, so everything we had before, plus any number that can be expressed as the ratio or the fraction a over b. This includes every fraction and any decimal that is terminating, which means it stops, or repeating. Okay, we'll look at some of those. All right, so again, you're going to have all of these numbers you had before. The 1, the -1, the 2, the -2, the 100, the -100, 8,000, the -8,000, and 0. Okay, but you're also going to have your fractions, so 2/3. -3 1/2, okay, all of those. You're also going to have your terminating decimals, so that would be like 4.2, -3.56, okay, and then it's also going to include your repeating decimals, so I don't know, -2.6 repeating, okay, or they may write it like this, -3.1515, ... okay, that's repeating even though it's not terminating. So those are all also rational numbers. The irrational numbers may be a new group that you haven't heard about before, but you have been working with them in this chapter. They're numbers that aren't expressed as fractions, but they are decimals. They're just decimals that don't what was left. We've got the repeating and the terminating, but what we don't have are the ones that don't terminate, don't stop, but they also don't repeat. So they're just numbers that go on and on forever. If you just kept going, the decimal would just keep going too. All right, so these are numbers that you may have seen when we did square roots of things that weren't perfect squares. So if you plugged them into a calculator, the calculator can give you a certain number of digits, but then it runs out of room. So the square root of 2 would be something like this, all right? It's repeating. Some of the numbers show up again, but they never show up in the same order. So this is not repeating. So this is an irrational number, square root of 2 would be an example. You also may remember pi or heard of pi. Pi is a number that just goes on and on and on forever. Okay, they've calculated like millions of places of pi, and they can't ever find a place where it repeats. So this is a non-terminating, doesn't terminate, and it doesn't repeat. So pi is also an irrational number. Okay, or they may just list it as, you know, a number. 3.16278134449. Okay, dot, dot, dot. It just keeps on going, right? Those are irrational numbers. And then your real numbers are all the rational numbers plus all the irrational numbers. Okay, so if you put all the rational and all the irrational numbers together, you have this system called the real number systems. And these are the types of numbers we're going to be working with this year. Okay? All right, so in the homework, what you're going to be asked to do is to classify numbers. Okay, so we're going to practice a few of these over here. So they'll give you a number, and then they're going to ask you to name the group of numbers that number goes in. So let's say they give you the number 5. All right, so you're going to look, and you're going to see it's not irrational, right? These are the weird ones. Okay, is it a natural number? Is it a number that you learn to count with? 1, 2, 3, 4, 5. Yes. Okay, so this is a natural number. It's also, if it's inside natural, right? If it's in the smallest group, it's in all of them. So if it's natural, then it's also whole. It's also an integer. It's also a rational number. And then remember, this is part of the real number system, so it's also a real number. Okay, let's try another one. Maybe you have 1/2. Okay, where would 1/2 go? Well, it's not natural. It's not a whole number. It's not integer. All the fractions go in the rational number sort of box. Okay, and again, if it's in rational, then it's also in the real number system. Let's try, how about a decimal? -3.6. All right, so it's not natural, it's not whole, it's not integer. Look, integers don't have any decimals. The only thing with decimals, okay, that stop, right, are the rational numbers. And if it's rational, it's also real. All of these are going to be real, right? How about this one? What if you have 2.671368 dot, dot, dot? Okay, so decimal means it can't be any of the natural, whole, or integers. The rational numbers have decimals, but they're decimals that stop and decimals that repeat. This one isn't stopping and it's not repeating. This goes over here. It's irrational, but it's still real. Okay, what about -4? Okay, is it a natural number? Do you count with negative numbers? Nope. So a whole number would just be these plus 0. It's not that one. Integer, is it considered an integer? Yes, it is. Okay, and then if it's inside integers, it's also going to be a rational number, and it's also going to be in the real numbers. Okay, let's look at one more. What do you think 25% would be? All right, so we don't have any percents here. But what do we know about percents? Can we change them to something we do know about? Well, if we go ahead and make the 25% into a decimal, move it 2 places, it becomes 0.25. All right, so decimals go where? They're either rational or irrational. Is 0.25 terminating or repeating? Well, it's terminating. It's just 2 digits. So that makes this a rational number. And if it's rational, it's also real, right? So I'm going to add that over here, 25%. Okay. All right, so you got your real number system made up of rational and irrational. Rational, remember, decimals that don't, that terminate, okay, or repeat, or all your fractions. Okay, irrational are those decimals that don't repeat and don't terminate. All right, see you soon.